In this episode, we're going to focus on a set of controls that look simple on the surface, but decide a huge amount about how safe and predictable your automation will be. Pipelines usually start because of a trigger, and some triggers happen automatically when code changes are pushed, some happen because a human clicks a button, and some happen on a schedule like a timed job. At the same time, pipelines often rely on variables that come from Git context, such as branch names, commit identifiers, and environment labels, and those variables influence what the pipeline builds and where it deploys. When beginners struggle with triggers and variables, they often experience pipelines that run at the wrong time, run with the wrong settings, or behave differently depending on where the run originated. Operators prevent that by treating triggers and variables as a single control system. The trigger establishes context, the variables express that context, and the workflow must validate that the context is both trusted and appropriate. Reliability here is not about luck. It is about designing consistent rules that reduce ambiguity and reduce the chance of accidental high-impact actions. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Push triggers are the most common automation starting point, and they are attractive because they feel effortless. You push a change, and the pipeline responds quickly, which creates a tight feedback loop for catching mistakes early. The operational risk is that push events happen frequently and can be generated by many sources, including human developers, automated systems, and in some cases external contributions. If every push triggers the same heavy workflow, the system can become slow and noisy, which encourages bypass behavior. More importantly, push triggers can start workflows in contexts that are not appropriate for privileged actions, such as deployments, because a push does not automatically imply approval. Operators therefore distinguish between push-triggered validation and push-triggered promotion, keeping validation broad and low risk, while gating promotion behind stricter conditions. Another beginner misunderstanding is to assume a push trigger always means the pipeline should run exactly the same way, but branch context, repository context, and trust context matter. A push to a feature branch should not necessarily behave like a push to a release branch, and the difference should be expressed intentionally rather than through guessy special cases. A reliable push trigger design starts with clear scope boundaries, which means defining which branches, paths, or change types should trigger which workflows. In a healthy system, push triggers for everyday development primarily run checks that are safe and useful, such as building and testing, while avoiding actions that change shared state. This reduces blast radius because failures remain inside the validation world rather than spilling into deployments. It also reduces cost because the pipeline does not burn resources running expensive jobs for changes that do not affect those jobs. Operators also think carefully about how push events interact with merging, because merges can generate their own events, and that can lead to redundant runs if not handled thoughtfully. A reliable design prefers predictable mapping, where the same kind of push always produces the same kind of pipeline behavior, and differences are tied to clear context like branch type. That predictability becomes important during incident response because the team can answer why a pipeline ran and what it was supposed to do based on the push context. Manual triggers solve a different problem than push triggers because they allow humans to start automation when a decision has been made. A manual run is often used for actions that are higher impact, such as deploying, promoting artifacts, or running expensive checks that are not needed on every push. The beginner mistake is to treat manual triggers as a free-form escape hatch, where anyone can click a button and run anything whenever they feel like it. Operator thinking treats manual triggers as controlled operations that must be constrained by identity, role, and intent. If a manual trigger can deploy to production, then the system should require that the person initiating it is authorized and that the target environment is clearly specified and validated. Manual triggers are powerful because they provide a clear point where human intent is injected into automation, which can improve safety when combined with approvals. They also provide a way to handle unusual situations, like redeploying a known good version after an incident. The goal is to make manual triggers predictable and auditable, not to make them casual and opaque. A reliable manual trigger also needs strong parameter discipline, because a manual run often involves selecting options like environment or version. If those options are unconstrained, a user can accidentally request a dangerous action, or they can supply a value that the pipeline interprets in a surprising way. Operators therefore prefer a small set of allowed options and clear validation rules, so the pipeline can reject ambiguous or unsafe inputs. This is a direct application of failing closed, where uncertainty leads to stopping rather than proceeding. Another operational detail is that manual triggers should separate preview actions from execution actions, meaning that a user can see what would happen before it happens for high-impact changes. Even if you do not implement a preview, you can still adopt the mindset that manual triggers should make intent explicit and should reduce the chance of accidental scope expansion. Manual triggers also become more reliable when they do not rely on hidden defaults, because defaults can change and humans can forget what they are. When manual runs always require explicit selection of critical context, the system becomes safer and easier to audit. Scheduled triggers are a third category, and they exist because some work needs to happen regularly, even when no one pushes code. Common examples include dependency checks, routine scans, backups of metadata, or periodic validation tasks that detect drift. The beginner risk with scheduled triggers is that they can run at times when systems are under load, or they can trigger workflows that assume a certain environment state that is not always true at schedule time. Operators treat scheduled triggers like background maintenance, which means they design them to be low impact, resilient to transient failures, and safe to retry without side effects. Scheduled workflows also need careful scoping because they can accidentally become noisy if they trigger alerts for conditions that are expected during certain windows. Another risk is that scheduled triggers can run on stale assumptions about code state, such as always running on a default branch that might not be appropriate for certain checks. Reliability in scheduled triggers comes from explicitly defining what code state they use and what outcomes they are expected to produce. When schedules are designed responsibly, they increase reliability by catching issues that would otherwise accumulate silently. Scheduled triggers also raise an important question about permissions and secrets, because running a workflow on a schedule often means running it without a human present. That makes the workflow's identity and scope especially important, because there is no person to notice if it runs in the wrong context. Operator thinking, therefore, prefers minimal privilege for scheduled jobs, and it avoids giving scheduled workflows broad deployment permissions unless there is a very strong reason. If a scheduled job is meant to scan dependencies, it should not need access to production deployment systems. If it is meant to validate drift, it should report findings rather than automatically applying changes, unless the system is designed for safe remediation. Another operational benefit of scheduling is that it can be aligned with maintenance windows, meaning you run heavier tasks when impact is acceptable. Even at a beginner level, you can understand this as timing work when the system can afford it. Scheduling is not just about time. It is about predictable load and predictable context. Now we bring get variables into the picture because triggers determine context and get variables express that context in a way workflows can consume. Get variables often include branch name, tag name, commit hash, and information about the event that triggered the run, such as whether it came from a push, a merge, or a manual start. The beginner trap is to treat these variables as trustworthy instructions rather than as data that must be validated. A branch name can be manipulated, a tag can be created with misleading naming, and event context can be misunderstood if workflows assume too much. Operators therefore treat get variables as inputs that can influence decisions, and they define clear rules about how variables map to environments and permissions. For example, a workflow might allow deployment only when a variable indicates a trusted branch and an approved event type. The key is that variables should be used to confirm context, not to bypass context. When variables are validated, they make automation flexible without making it unsafe. Reliability also depends on the consistency of variable usage across workflows, because inconsistent variable conventions create confusion and errors. If one workflow interprets a branch label one way and another workflow interprets it differently, you get unpredictable behavior, especially during high-pressure situations. Operators prefer a small set of consistent conventions, such as standard branch naming and clear mapping from branch types to environments. They also prefer to avoid complex string parsing in pipelines because parsing logic tends to break when naming conventions evolve. Instead, they prefer explicit metadata where possible and strict allowed values where feasible. Another operator habit is to separate user-provided variables from system-provided variables, because user-provided variables are more likely to be malicious or mistaken. When you separate those sources, you can apply stricter checks to user-provided values and treat system-provided context as more trustworthy, though still not unquestioned. This discipline reduces the chance that a clever naming trick causes automation to target the wrong environment. Push, manual, and scheduled triggers also interact with get variables in ways that can surprise beginners, because the same variable can have different meaning depending on the trigger type. A push-triggered run might have a branch context that reflects what was pushed, while a manual run might allow selecting a branch or a version, and a scheduled run might always reference a specific branch by default. If your workflow assumes one meaning but the trigger provides another, you can get behavior that feels inconsistent. Operators address this by explicitly branching logic on the trigger type, meaning the workflow treats manual selection differently than push context, and it treats scheduled context differently than both. This is not about adding complexity, but about making the workflow honest about how it was started. Honesty here is a reliability control because it prevents hidden assumptions from driving decisions. If a manual trigger can specify a target version, the workflow should validate that version is approved for the intended environment. If a scheduled trigger runs on a default branch, the workflow should confirm that is correct before running expensive or risky steps. Another important reliability concept is protecting the pipeline from variable injection and unexpected expansion of scope. Variable injection can happen when values are interpreted as code or when they influence file paths, command options, or environment selection in unsafe ways. Even without implementation detail, you can understand the risk. If a variable can change what gets built or where it gets deployed without strong validation, it can become a shortcut for unintended behavior. Operators reduce this risk by limiting what variables can control and by validating values against known safe patterns and allowed sets. They also avoid using variables as direct selectors for privileged actions unless those variables come from trusted sources and are confirmed by policy. In manual triggers, this means guiding the user with constrained choices rather than allowing free-form text. In push triggers, it means not allowing arbitrary branch names to be interpreted as deployment targets. In scheduled triggers, it means not allowing schedule context to bypass normal checks. Reliability grows when the workflow treats variable values as data that must be proven safe, not as instructions to be obeyed blindly. It is also useful to think about how these triggers and variables affect audit and incident response, because the evidence trail is part of reliability. When a deployment happens unexpectedly, you want to know whether it came from a push event, a manual run, or a scheduled trigger, and you want to know which variables were in effect. That allows you to reconstruct why the pipeline behaved the way it did and whether the behavior was correct. Operators therefore favor workflows that record trigger type and key contextual variables in their run metadata, because that metadata becomes a quick reference during troubleshooting. This also supports learning, because if a manual trigger caused an issue due to a confusing option, the team can refine the option set and reduce future risk. If a scheduled trigger ran at a bad time, the schedule can be adjusted. If a push trigger ran unexpectedly due to a naming rule, the rule can be clarified. Reliability improves when the system's behavior is explainable after the fact, not just during design. A common misconception is that reliability means fewer triggers, when in reality reliability comes from having the right triggers with the right guardrails. Push triggers are excellent for rapid validation and early detection, but they should not automatically promote high-impact changes without additional checks. Manual triggers are excellent for controlled actions and explicit intent, but they should be constrained and auditable rather than casual. Scheduled triggers are excellent for routine maintenance and drift detection, but they should be low impact and carefully scoped. Get variables are excellent for making workflows context-aware, but they must be validated and used consistently to avoid unsafe behavior. Operators do not fear triggers. They fear ambiguous triggers and unvalidated variables. When you remove ambiguity, Triggers become tools for control rather than sources of surprise. That is the difference between a pipeline that feels random and a pipeline that feels dependable. To close, configuring push, manual, and scheduled triggers reliably is about designing how automation begins, under what conditions it can act, and how it interprets context through get variables. Push triggers should prioritize safe validation and clear branch-based behavior, so runs are predictable and low risk. Manual triggers should inject human intent with strong identity, constrained parameters, and auditable outcomes, especially for high-impact actions. Scheduled triggers should provide routine assurance and drift detection with careful load timing, minimal privilege, and resilient behavior under transient failures. Get variables should express context in a consistent way, and workflows should validate those variables rather than blindly trusting them, especially when they influence environment targeting or permission use. When these elements are aligned, pipelines become more than automated scripts. They become controlled systems that respond predictably to change and intent. If you can explain how trigger type and variable validation shape safety and reliability, you're building the operator mindset that keeps automation fast without letting it sprawl into unpredictable behavior.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.